Welcome back to All This Math. This is Professor Parker. And for this next lesson, or this next problem, I should say, we're going to be solving a trigonometric equation. Okay? So let's take a look at the equation. It says 3 times secant squared of x minus 4 is equal to 0. So since we're trying to solve this equation, that means we're trying to solve for x. We're trying to solve for x, meaning we're trying to isolate x by itself on the left side of this equal sign. Right now, it's a bunch of other stuff on the left side of the equation with the x. All of that stuff we're going to get rid of mathematically. So that means we're going to get rid of this negative 4. We're going to get rid of this 3. We're going to get rid of this exponent 2. And we're going to get rid of this secant. All right? This secant function. All right? And we're going to have x isolated by itself. Okay? So let's get started. And before we actually get started, what does this mean right here? This means that we're looking for all the solutions of x in the entire unit circle, from 0 all the way around to pi over 2 up at 90 degrees, and then to pi at 180, and then 3 pi over 2 at 270, and then back to 0, but 0 is the same thing as 2 pi. So we're looking for all the solutions that satisfy this equation around the entire unit circle. All right, the entire unit circle. Okay? So, let's get started. What I would do first is I would get rid of this negative 4. I would get rid of this negative 4, and then that would, reduce the amount of terms that are on the left side of the equal sign. Because again, always start with your end goal in mind. My end goal is to get x by itself. That's what it means to solve. Get the variable by itself. Solve, get the variable by itself on one side of the equal sign. So I'm going to get rid of this negative 4. Now, how do I do it, though? I can't just randomly just cross it off. Now, I got to do something mathematical to get rid of it. I do the opposite, or the inverse operation. The inverse of subtracting 4 is adding 4. So I'm going to add 4, right? I'm going to add 4 right here. And because it's an equation and I got to keep everything balanced, if I add 4 on the left side, I got to also add 4 on the right side. So I'm going to add 4 to the 0. So these add up to 0. This becomes a 4. And then everything else just drops straight down. So I got 3 times secant squared of x is equal to 4. All right, now I'm getting closer to x, right? I got to get rid of this 3. I'm going to get rid of the 3 next, right? So the way I get rid of this 3 is because this 3 is involved in multiplication. It's part of a product. 3 times secant squared of x. I do the inverse operation to get rid of the 3. The inverse of multiplying by 3 is dividing by 3. All right, or, if you want to, you could think of it as multiplying by 1/3. Either multiply by 1/3 or divide by 3 are inverses of multiplying by 3. But let's do this. Let's divide by 3 on the left side, divide by 3 on the right side. So these 3's cancel out and turn into 1s, leaving us with just secant squared of x is equal to 4/3. All right. Now, I'm trying to get rid of this exponent. I got to get rid of this exponent. This exponent got to go. So the opposite of squaring something is taking the square root of something, or the inverse. Inverse opposite mean basically the same thing. The inverse of squaring something is taking the square root of something. So what I'm going to do next is I'm going to take the square root of the left side, and I'm going to take the square root of the right side. All right, so I'm going to rewrite it as secant squared of x is equal to, now be careful, whenever you take the square root of both sides of an equation, you need to account for the fact that you will have a positive and a negative value, right, on the other side of the equal sign, right? So I can't just say square root of 4/3, right? If you remember doing work with the quadratic formula, how the quadratic formula has that plus or minus symbol on it, right? Because there's a positive value and a negative value, right? We do the same thing here because we're taking the square root of both sides. So I put the plus or minus sign. That's the plus sign and over top of the minus sign. And then I'm gonna have the square root of 4/3. All right? I'm gonna have a positive value and a negative value. And the reason for that is, like, think about it like this, right? If you want to know the square root of 9, the square root of 9 is 3. But it's also negative 3. Why is it negative 3? Because what's negative 3 times negative 3? Positive 9. So therefore, the square root of 9 is not only positive 3, it's also negative 3. Hence, plus or minus 3 is the square root of 9. So when we take the square root of something in an equation, we put the plus or minus sign symbol to show that. All right? Now, these are inverses. The square root and the square root and the square are inverses. So they basically cancel each other out. So that leaves me with the secant of x is equal to plus or minus. And then the square root of 4/3. 4 is a perfect square. So that's going to turn into 2 in my numerator, just plain 2, not the square root of 2. I know a lot of people like to do that. They make that mistake all the time. The square root of 4 is just 2. It's not the square root of 2. It's just plain 2. Once you use the radical sign or use the square root symbol, it's gone. You used it already. So I used it on the 4, so it's gone. Now the 3 is not a perfect square. So I'm going to keep that as just the square root of 3. Now this is not rationalized because typically we shouldn't have radicals in the denominator in a fraction. That's just not good form. That's not sophisticated, right? I'm gonna do something about that in a minute though. So here we go. We got secant of x is equal to plus or minus, so positive 2 over root 3 and negative 2 over root 3, right? What I'm gonna do is I'm gonna change this secant into its inverse because I like to deal with sine, cosine, and tangent. I like to focus on sine, cosine, and tangent. And I know that secant is just the reciprocal of cosine. So I could do this. I'm gonna write it down here. So 1 over cosine of x is also equal to plus or minus 2 over the square root of 3. All right, but now I want to solve for cosine of x because I got cosine of x in the denominator of this, but I just want plain cosine of x. So to do that, what I would do is I would cross multiply, go diagonal and go diagonal, right? So I'm gonna do this, and I'm gonna do that because that's a proportion basically, right? So what I'm gonna do is I'm gonna come up here with it. Now I got 2 times cosine of x is equal to plus or minus square root of 3. That plus or minus sign is still there on the right hand side, right? Because I did 1 times the square root of 3, that gave me that. I did 2 times cosine of x, that gave me that. All right, and now my goal was to get cosine of x by itself, so I'm gonna get rid of this 2 by dividing by 2 on the left side and dividing by 2 on the right side. All right, so these 2's are going to cancel out. So we got cosine of x is equal to plus or minus root 3 over 2. So now what I'm trying to do is in order to find x, I need to find the angle that has a cosine value of root 3 over 2 or a cosine value of negative root 3 over 2. Now, I should have these memorized, right? I should. Unfortunately, right now, I don't. I forget them. Like over the years, I've learned this, then forgot about it, then learned it again when I had to teach it, then forgot about it, then learned it again, then forgot about it, then I tutored somebody, learned it again, then forgot about it. I'm like, I forget. But the important thing is, we know how to access our resources. We know how to find a unit circle online and print it out, right? So all I do is I go to the unit circle, right? And I find the angles that have a cosine of square root of 3 over 2 or negative square root of 3 over 2. So if I look in the first quadrant, I see that pi over 6 has an x coordinate because our cosine corresponds to the x coordinate of the angle. I'll say that again. Our cosine corresponds to the x coordinate of the angle. So pi over 6 has an x coordinate of positive square root of 3 over 2. So that means one of my x values is pi over 6. All right. Now we go to the second quadrant. In the second quadrant, 5 pi over 6 has an x coordinate or a cosine of negative square root of 3 over 2, which is cool because I want that too because it says plus or minus. Plus or minus. So don't forget about that. So also I'm working with 5 pi over 6. Then I go to the third quadrant and I see that 7 pi over 6 has x coordinate or a cosine value of negative square root of 3 over 2. So now I got 7 pi over 6. And then I go to the fourth quadrant. In the fourth quadrant, I see 11 pi over 6, which is the same as 330 degrees. And you notice that because our first solution was pi over 6, which is 30 degrees basically. All of our solutions have a 30-degree reference angle. This is 150 degrees, which has a 30-degree reference angle. This is 210 degrees, which has a 30-degree reference angle. Make sure you understand reference angles as they pertain to the unit circle, all right, in order for that to make more sense to you. Now, I'm in the fourth quadrant, and I was talking about 330 degrees and 11 pi over 6. So you see how This particular equation has 4 different solutions because all 4 of these solutions will give you a true statement, right? So if I take like the secant of pi over 6, the secant of pi over 6 is just 2 over the square root of 3, because that's the inverse of cosine. So basically, because the cosine of pi over 6 is square root of 3 over 2. So the secant of that is the flip of that, the reciprocal of that. So that'd be 2 over the square root of 3. You square that, you get 4 over 3, right? And then you do 4 over 3 times 3. And we just follow order of operations, right? Just regular everyday order of operations. 4 over 3 times 3 is going to give you 4. This whole thing becomes 4. 4 minus 4 equals 0. So pi over 6 is good. All of these are going to be good, right? But I recommend to you to check all of these answers to make sure that they're all good. Make sure 5 pi over 6 is good. Make sure 7 pi over 6 is good. Make sure 11 pi over 6 is good. All right. Now, I just showed you how to do this. Now, it's your turn to go get some practice, right? It's not enough just to watch the video and think you're going to understand it, because you probably won't. You watch the video. If you haven't done any practice, an hour later, 2 hours later, definitely 24 hours later, you're going to probably forget how most of the steps I did. You got to like get your hands dirty, get some practice, do at least 10 problems. All right. So use this video as a guide, use this example as a guide, and go on to get some practice, and I'll catch up with you in the next video. Peace.